and Sylvie.
Hey, Louis.
So I have this physics problem I want to talk to you about. Circular motion. I have a coin on a turntable. So this is my turntable, this is my coin. So this thing is going to rotate. Okay, back and forth. This is the top view, and here's the side.
Okay, I see.
So what do you think the forces are on the coin?
Well, okay, we have, of course, gravity, the normal force, and then friction force.
Yeah, and that's it, right?
Right.
Because it's just touching one surface. So it's going to have gravity, normal force, and friction. Okay, let's draw a free body diagram. So first, we should define the coordinate system. In circular motion, the best system to use is a radial direction, tangential direction, and z direction. So if I take the side view here, the radial direction will be this way, towards the center, radial. And the tangential will be in and out of the board. We don't really need it, so I'm not going to write it. And then we have the perpendicular direction, z. All right, so this is my coordinate system. So what is the free body diagram? Which way is the normal? Which way is gravity?
So normal force will be along the the vertical axis.
Right.
And as well as gravity, right?
Right.
Well, now for the friction force, should be horizontal, but in which direction?
So we know the acceleration, right?
Yes.
It's a circular motion, so the acceleration should be towards the center.
So it has to be that the friction force has to be towards the center as well.
Exactly. This is our centripetal force, it's static friction. So here's a problem for you. So what if I had another coin in the middle?
Oh.
Okay. And the question is, I'm going to gradually increase the angular velocity at which I turn the turntable. Which coin will fall off first? Think you can solve that?
Right. So my omega here is constant. Well, let's see. If I use Newton's second law, I can write that the friction force is equal to the mass times the centripetal acceleration. Note that this is Newton's second law along the radial direction. And since there is no other force than the friction force, that's all I have on this side of the equation. Now, I know that the centripetal acceleration is equal to m omega squared times r.
Wait, I prefer to use v squared over r.
Well, here in this problem, omega is constant, so it's easier to use omega squared times r rather than mv squared over r.
Okay, so then which one will fall first?
Well, you see that we have an r dependence here. So the static friction will become higher for the one that has a higher radius for the same angular velocity. So that means that this second coin will fly off first because
it will reach, it will reach a static, for a given omega, the one that's farther away should reach its maximum static friction first.
Exactly.
All right, let's try it. See, I have my two coin, my turntable, and this is going to turn, and again, the only force that can provide the centripetal acceleration is static friction. And we're saying that this one should reach its maximum static friction first. So this one should take off first.
Well, let's see what happens.
Yeah. Turn this on. All right, we just need to increase the voltage. Maybe we can continue, see when that one goes off.
Right.